Welcome to the Foundry by Forge College. Step right onto the shop floor because today we are officially firing up the machines. I am incredibly excited to guide you through today's explainer, where we are tackling the absolute peak of our advanced anchor concepts track, the Capstone build and integration. Think of this as the final assembly line. Coming off our last lesson with the mini project where you implemented those advanced patterns, you've essentially forged all the individual gears, right? You've tested the tensile strength of your materials, and now? Well, now we actually bolt this incredibly sophisticated smart contract together. We are going to synthesize your optimization plans, your complex data structures, your security checklists, and your modular patterns into one cohesive review-ready masterpiece. So, throw on your safety goggles and let's get to building. Here's a quick look at our assembly index for today. First, we'll hit the master blueprint recap. Second, assembling the core components. Third, security and vibe coding. Fourth, quality assurance checkpoints. And finally, Section 5, making sure you are ready for code review. All right, let's dive right into Section 1, the master blueprint recap, gathering your components. I really want to reassure you right off the bat here. The heavy lifting, it's already done. Seriously, look at the input artifacts you're bringing to the table. From Lesson 1, you've got your optimization plan, meaning your profiler notes and instruction count targets. From Lesson 2, you have your complex data structures, like those beautifully packed account structs and hierarchical layouts. Lesson 3 provides your rock-solid security checklist and threat model. And Lesson 4 gives you the working, unit-tested modular code from your mini project. We are simply taking these 4 distinct artifacts and funneling them into a single, highly optimized Capstone repository. It is all about synthesis now. Moving right along to Section 2, assembling the core components, bolting the machine together. Let's walk through the actual mechanical steps of your build. Step 1, consolidate your layouts and pack those accounts. Think of account packing like packing a suitcase for a really long trip, you know? You want everything super tight, perfectly aligned, taking up the absolute minimum amount of space so you can save on rent costs. Step 2, implement your optimized entry points and batching. Because by combining related state changes, you're going to save incredibly valuable compute units. Step 3, wire up your security checks directly to your tests, which we'll definitely dig into more in just a minute. Step 4, add those final integration endpoints, things like paginated queries or off-chain indexing hooks. And finally, Step 5, benchmarking and profiling, just to prove your machine is genuinely as fast as you promised it would be. Now, keeping a clean, predictable repository is literally half the battle. Listen, in the various learning tracks and developer programs we facilitate naturally over at Forge College, we constantly see one universal truth. Your code reviewer does absolutely not want to go on a scavenger hunt. So keep your anchor source code in the programs folder. Your test suites, they go in tests. All those super handy automated validator boot files go in scripts. Your profiling traces live in benchmarks. And critically, your optimization reports, state diagrams, and security checklists belong right there in docs. Trust me on this, impeccable organization is the hallmark of a senior engineer. Okay, Section 3, security and vibe coding, adding safety valves. So, let's talk about vibe coding. Using an AI-assisted workflow is an absolutely incredible force multiplier, but let's be crystal clear, it is not a replacement for your engineering brain. You can feed an AI a failing test description and a minimal code snippet and ask it to generate a test template or maybe a small refactor. It's fantastic for speeding up all that tedious boilerplate, but here's the major catch. You must maintain strict human-in-the-loop verification. Always run and verify the generated code before you commit it. Vibe coding is amazing as long as you don't blindly copy-paste and let the AI accidentally build a toaster when you explicitly ask for a secure smart contract. And when it comes to security, vague promises simply do not cut it. You need to map every single security control from your threat model directly to a precise test and a specific code pointer, like the exact file and line number, right inside a security mapping markdown file. And remember, we need to see both positive and negative path tests for your authority checks. We actively want to see your code deliberately fail and throw exact anchor error codes when it encounters malformed inputs or unauthorized access, because a truly secure machine knows exactly when to shut itself down. Next up, Section 4, quality assurance checkpoints, testing the machine. Here is a bit of a reality check regarding software engineering that you just have to embrace. You won't always hit every single performance target you boldly set back in Lesson 1. And honestly, that is perfectly okay. Compare your new benchmarks to your original goals. If you hit your compute unit targets, fantastic, celebrate that. But what if you missed an instruction count target because you realized halfway through that you needed a much more complex, secure serialization method? Just document exactly why. Providing a concrete, well-reasoned engineering justification for a trade-off is a perfectly acceptable outcome, and frankly, it shows real maturity as a developer. So these 5 verification signals are your final gauntlet. Before you even think about calling this project done, you need to capture and commit these exact outputs. 1. The log showing your test suite passes with flying colors. 2. Your benchmarking traces proving your performance. 3. That completed security mapping file we just talked about. 4. A log from your integration smoke test script proving your new endpoints actually work. And 5. A transcript or short video clip of your reviewer runbook in action. Once you have all 5 of these green lights, you can confidently tag your release as Capstone milestone.
And finally, Section 5, ready for code review, shipping the Capstone.
Let's be honest, code reviewers are incredibly busy people. Their ideal scenario is to validate your entire complex machine as quickly and painlessly as possible. By providing a clean reviewer runbook with exact commands right there in your README, you are essentially giving them a VIP fast pass. Within 1 minute, they should be able to run your automated tests. Within 5 minutes, your helper scripts should let them boot a local validator and run an integration smoke test. And within 30 minutes flat, they should be able to complete their full verification of your optimization, your serialization, and your security checks. If you make their life easy, they will absolutely love your code. And wow, that brings us to the end of our Capstone assembly. You have successfully taken abstract concepts and synthesized them into a highly optimized, beautifully structured, and deeply secure Anchor repository. Take a second to really celebrate that mastery. But as you know, the journey of an engineer never really ends. You've conquered Anchor and Solana development tools, but are you ready to face the strict, unforgiving power of the Rust borrow checker? Getting deeper into core Rust syntax is going to unlock even lower-level optimizations and safer serialization for you. To continue your Web3 learning journey and dive into those advanced concepts, be sure to visit forge.college to explore more. Thanks so much for joining me on the shop floor for this explainer today, and I will see you in the next one.